name is Sakesh from Engineering College 9. Today we are going to study one more important topic, that is. Hi students, one more problem we will do today. We will discuss determine the backwater curve problem. Determine the length of backwater curve caused by an afflux of 2 meter in a rectangular channel of width 4 meter and depth 2.5 meter. The slope of the bed is given as 1 in 1000. Take the value of Manning's constant n is equal to 0.03. That is the problem they given in that questions. 1100. This is 1100. Sorry, that. And here first, before we need to know that what is the backwater curve, that we need to discuss. Backwater means, so the water is flowing, this is the bed of the canal, and this is the surface, the bed of the canal, and this is the dam. Is here we constructing one dam. So here that profile, the water is flowing from here, gradually increasing water, and it's crossing here. The what profile is creating from here to here, that is called backwater. So gradually increasing the water. So gradually increasing the water, that is called backwater flow. That is d1, height will gradually increase, height h1 and h2, h3, h4, h5, like that. And here that changes will happen, final happens, and that initial and final height, that is called minimum height and final height, that is called afflux. The minimum height and maximum height, that is called afflux. What is the data they given in this diagram question? You just find it. What is the data they given? First one is width of the channel they given, b is equal to 40 meter. They given width of the channel is b is equal to data given. Data width of the channel b is equal to 40 meter they given, and afflux, that also given. I said minimum height and maximum height changes, that is called afflux, and that also they given. We can write it h2 minus h1, so that value they given 2 meter, that also they given. And next, depth of the channel they given. Depth of the channel, that is h1 is equal to 2.5 meter. This height, this depth of the channel from here to here, this is slope IB. Depth of the channel, that they given 2.5 meter, and h2 is equal to h2 minus h1 is 2 meter. So h2 we can find out. So h2 minus h1, this is, we can write it h2 minus h1 is afflux they given, and we need to find out here what is the value of h2. How we can find out? 2 plus 2.5, 2 plus 2.5, 2 plus 2.5, so 2 plus 2.5, it is 4.5 meter. So next we can write it. So this is the values they given, and that next the slope also they given, bed slope. Bed slope they given, IB is equal to 1 divided by this bed slope is this. So value is 0. One sec, sorry for interruption. Answer is IB is equal to 1100. We can write it. Answer is 0.000909. So then what is the given? The Manning's constant they given. The value is n. Manning's constant n they given 0.03. Manning's constant n they given 0.0. And we know that the area of the flow section, this is, we can consider this is a rectangular channel, area of the flow section. I said this is a rectangular section. If we consider cross section, we will find it b and h value. B and h value we can find it. So area of the flow section A1 is equal to B1 into H1. So B into H1. So that answer is B value is 40 and H1 value is 2.5. So rectangular channel width is 40 meter and depth 2.5 meter. They given in the questions. So answer is 100 meter square. Area is equal to 100 meter square. And wetted perimeter P is equal to B plus 2H1. So that is B is equal to this width. B is equal to 40 meter. P is equal to 40 and H is equal to height. That value is 2.5. Then 40 plus 2 into 2.5. So what is the answer? One sec, I will check the answer. Answer is 45 meter. Hi students, today we'll discuss about in that one backwater length problems. So here what is the problem here? They're given in problems. Determine the length of the backwater curve caused by an afflux of 2 meter in a rectangular channel of width 40 meter and depth 2.5 meter. The slope of the bed is given as 1 in 11,000 and take value of Manning's constant n is equal to 0.03. So here we need to find out the what we need to find out here in this question, length of the backwater curve. We know that formula E2 minus C1 divided by IB minus IE. It means IB means bed slope and IE means energy slope. So that we in here in this diagram as I drawn here, that's backwater here. This is the dam structure. I can say this is the dam structure. So this is the dam structure. So here the water storage is there. Here some slope will create because this is the surface of the earth and here some canal slope. So that we can say the bed slope or IB. IB we can write it this one. This one is a bed slope. And this is the depth of water, H1, H3, H4 and this is H2 final water, maximum height, and this is H1 is minimum height. So here one profile will create, that is called backwater. So because of that, when before storage of the dam, when it reaches to near of dam structure, so some profile is creating, that is called backwater curve. So what is the length of the backwater, that we need to find out here. So the maximum height, this is the maximum height H2 and this minimum height H1, that separation, that height is called afflux. Afflux is maximum height minus minimum height, that is called afflux. So we can write it, afflux is equal to maximum height of water minus minimum height. Maximum height minus minimum height, that is called afflux. So here that afflux they given direct in that questions. So what is the value of afflux is 2 meter. That afflux value they given 2 meter in the direct question itself they given, and breadth B is equal to 4 meter. Here they told that is rectangular channel. The channel is rectangular, so the breadth is 40 meter and depth of the channel is 2.5 meter. Depth of the H is equal to 2.5 meter. So we know that one afflux is called, as I told, maximum height by minimum height. So H2 minus H1, this one H2 minus H1 is 2 meter. So here H1 is they given. How we need to find out H2? H2 is equal to, here this one afflux is H2 minus H1. So H1 is equal to 2.5 meter. How we can find H2? Is equal to 2 plus 2.5. That is 4.5 meter. We'll get bed slope IB. Always if they are given slope means we need to divide that one. 1 divided by 11,000. The value is 0.000909. Bed slope is IB. I said this is the bed slope. This slope is, we can call it as bed slope. And energy slope is what we are creating, total energy line. The slope is, we said, energy slope. That is, we can call it as IE. And n is equal to 0.03. The Manning's constant they given, n value is 0.03. Here this is the cross section, so that we can find it of B and H value here. If they are given cross section means we can find out value of B and H. So how we can find out B and H value here? I can say this is the cross section like this. This is the cross section like this. Here we can find it B value and this is the H value. This is the cross section. So B we know that what is the value of B. That in the diagram question only they given B is equal to 40 meter and h is equal depth is what is the value? The depth is 2.5 meter. So we can find it area, that is 100 meter square. So P is equal to wetted perimeter. So these 2h is wetted perimeter. So we can B plus 2h1. So that is wetted perimeter P value. That also we can find it because we are having the value of that one. So we can find it wetted perimeter. What is the wetted perimeter value? P is equal to 40 plus 2 into 2.5. So it means value is 45 meter. The wetted perimeter value is 45 meter. 45 meter. Wetted perimeter is 45 meter. So if they given Manning's constant means we can go for Manning's equation. What is the Manning's formula? We know that one. Before going to that, we need to find out mean depth, because sometimes we are forgetting that one, mean depth. Why means because we are not good. If you don't know the formula, then how we can do that hydraulic mean depth? Because if you write the formula first, initial step, then you can go for hydraulic mean depth. So that reason we should know the formula. So what is the formula for velocity? That Manning's formula, V is equal to 1 by n m to the power 2 by 3 into slope of the bed IB the power 1 by 2. That is the using Manning's formula. This is the Manning's formula. It is Manning's formula. So here m means, here what we need to find out, m means hydraulic mean depth. Many problems we solve in related to that one. M is equal to A by P. It means A is mean hydraulic depth divided P is equal to this one perimeter. So here the two sections, section 1 and section 2 is there. So first we will go for section 1. That is, we can write it section 1. Here in the diagram also, section 1, m is equal to A5. Here we two section, we will go for the two section. The section 1 and this is section 2. So m is equal to A by P. So here area is equal to, what is the area? We know that area of the rectangular section is section 1 100 divided P also we calculated. What is the P value? Calculated is 45. So answer is 2.22 meter. 2.22 meter. So velocity formula, we are having 1 by n value we are having 0.03, and m value we got now 2.222 meter, 2 by 3, and remaining IB value also we are having, and we can find it out what is the velocity at section 1. Now we calculate what is the velocity at section 1 using this formula. Velocity at section V is equal to 1 by n m 2 by 3 and IP 1 by 2. So we can write 1 by 0.03 into 2.22 to the power 2 by 3 into IB, the value, bed slope we calculated 0.000909 to the power half. So what is the velocity? Answer is 0.54 meter per second. 0.54 meter per second. So we know that formula of this the formula of length of the backwater, finding out the formula. Length of the backwater formula, that we know that formula is, what formula? E2 minus E1. Very simple formula. E2 minus E1, slope of the bed and slope of the energy. Okay. So E2 is the energy equation is, we can find it out, V1 square, or here section 1, this is energy at section 2 and this is energy section at 1, and this is the bed slope and this is the energy slope. And energy at section 1, we are having the general formula for energy. For general formula we are having the energy, we all know energy formula, V1 square by 2G E1, energy at section. General formula we know that one, V1 square by 2G plus H1. So here V1, what is the value of V1? 0.5 square. 0.5 square divided by 2 into 9.81 G plus H1 value. H1 value we know that one, 2.5. V1 we got it by the Manning's formula, 2.5. So answer is 2.5148 meter. Answer is 2.5148 meter. So that is E1 value we got. The same we need to go for V2 value, because go for section 2, but here no need to calculate again V2, that because we can use for continuity equation and we can solve the formula. So that we can write it here. We got the value of V1 and we got the value of V2, and this equation we are having the equation. Next we know that continuity equation, section at 2 we go for section 2, this section. We are having the formula V1A1 is equal to V2A2. So rectangle channel A1 and A2 also almost same. No, it is same only, and the formula is, we can write it, V2 is equal to this, we need to find out V2 equal to V1 A1 divided by A2. V1 is equal to 0.54, V1 is equal to 0.54, and A1 is equal to 100 meter square. We know that 100 meter square, and that is, sorry, A2 will change because here H2 will change, no? That's the reason A2 will change. So V1 we find it out value, that is 0.54, and A1 is divided by 100, and B is equal to A2 is equal to B value, that is 40, and H2 value, it will vary, no? H2 value, that is H1 is, we know that one, 2.5, and H2 value 4.5, that is we calculated, so that reason it will change. So what is answer? V2 answer is 0.3 meter per second. V2 is equal to 0.3 meter per second. 0.3 meter per second. So no need to repeat again that V2 equation. So this equation we can find out. This is the continuity equation. This is the continuity equation. This is the continuity equation. V1 A1 is equal to V2 A2. So we know that value of V1 A1 and A2 value. So we find out the V2 value. So using that one we find it out. So we calculated 0.3 meter per second. That is value is V2 value we got, that is 0.3 meter per second. So next we need to find out area A2 how we can calculate. Next we need to calculate area 2. A2 value. So A2 value is B into where area A2, where area A2 is equal to B into H2. So B is equal to value is 40 into H2 value we already calculated H2 minus H1, in that we got it. Answer is 180 meter square. So wetted perimeter at section means, wetted perimeter how we can calculate it? At section 2 we know that when P2 is equal to B plus 2H2. So answer is 40 plus 2 into 45. 40 plus 2 into 4.5. Answer is 49 meter. 49 meter. So what is the hydraulic mean depth at 2? Hydraulic mean depth at section 2 means, hydraulic mean depth at section 2 is M2 A2 divided by P2, 180 divided by 49. So answer is 3.6. Answer is 3.693 meter. And specific energy at section 2. We calculated specific energy at section 1 and calculated specific energy at section 2, E2. If we have in the formula, next specific energy at section 2. That E2 is equal to H2 plus P2 square by 2G. H2 plus P2 square by V2 square by is equal to 0. So it means 4.5 plus 0.3 square into 2 into 9.81 is equal to 4.504 meter. So what is the, find the average velocity? Average velocity, how we can find the average velocity? Equal to H average is equal to H1 plus H2 divided by 2. H1 plus H2 is divided by 2 is equal to H1 is equal to 2.5 plus 4.5. H average, find the average velocity. H1 we know 2.5, H2 is equal to divided by 4.5 is equal to 2 is equal to 3.5 meter. 3.5 meter. And V average velocity is equal to, that we need to calculate. Find average velocity and average depth. Average depth also we need to calculate. And what is the V average? Average velocity. We can calculate. V average velocity is V average is equal to V average is equal to V1 A1 divided by A average. V1 A1 divided by A average, that is V average. Then we can write it this one V1, we can write it this V1 into B into H1, V1 into B into H1, B into H into average, H into average. So B will cancel. The answer is V into H1 divided by H average is equal to, what the answer is, V is equal to, we know, 0.454 into 2.5 divided by H average is 3.5. So answer is 0.3857 meter per second. 0.3857 meter per second. So what is the hydraulic mean depth average? That also we need to calculate. What is the mean depth average? Hydraulic mean depth average. That also we need to calculate. Mean depth. We are getting two values here. So M average is equal to M1 plus M2 divided by 2. That means 2.22 plus 3.673 divided by 2 is equal to 2.9465. To find the values of IE in Manning's formula, we need to find out the IE, because we having the formula L is equal to length of the backwater E2 minus E1 divided by IB minus IE. Here we find out this one and this one, this we know, that this value we don't know, that we need to find out IEV value. So IEV is equal to, how we can find, to find the value of IE using the Manning's formula. Use Manning's formula. V average is equal to 1 by N, this for all parameters. M average is equal to 2 by 3 into I to the power E 1 by 2. So this is the equation. So we can write it this one, V average is equal to 0.3857, 1 by N is equal to 0.03, M is equal to 2.9465 to the power 2 by 3, and I value 1 by 2. Answer is 68.534 I to the power E 1 by 2. So IE value is 0.3857 divided by 68.534 to square. Answer is 0.0003167. So L value is equal to, we can substitute this equation in for backwater curve length formula. E2 minus E1 divided by IB minus IE. answer is 4.504 minus 2.5148, and IB, the bed slope value is 0.000909 minus 0.00003167. So answer is 33584.3 meter. This is a final equations what we got in the length of the backwater formula. So this is the answer for that one. This is a very important problem. So here what we done, we are having that equation E2 minus E1 divided by bed slope minus energy slope. We find out the general, using this general formula we find out this equation E2 we are having general equation, V1 square by 2g, general equation V1 square by 2g plus H1 we using for E1, and E2 value V2 square by 2g plus H2, that is E2 value. So after that bed slope we know and energy slope we know that we calculated. So and the average for energy slope, for total energy line slope, find out how we can find out the equation total energy slope, average velocity. We are having the H average is equal to H1 plus and V average. So we having the formula for this one, using Manning's formula for we find out the value of IE. So if you remember this formula, we can find it out easily, and we can easily calculate all the parameters. So we should remember this formula: L is equal to E2 by E1 minus IB minus IE value. So it's very much necessary to remembering that formula. So we'll go for next problem. Previous class we discussed about how with the backwater profile dH by dx is, we are studied about dH backwater profile dH by dx is greater than 0. So it means y0 we can write, and this one what we can say that gradually that also different types of graph we are drawn. If it is greater than 0, that is we can say subcritical flow at normal depth. This one we can say subcritical, this everything we discussed in last previous video. Subcritical flow at normal depth, normal subcritical flow at normal depth. This one we discussed, and the diagram will come and like this, right? Now this we are considering at what is mild slope. This one we can consider as a mild slope, symbol mild slope. This one we can write it at mild slope. That is also one more condition. We consider the different profile. And steep slope, and YC is we can say less than the 0, y0, less than y0. What happens? We can call it a steep slope. YC is less than 0. This one we can consider dH by dx is called steep slope. Steep slope. Steep slope that we drawn in the everything we discussed in last previous video. Steep slope drawdown curve that we can call as steep slope. So this is also different, and critical slope y is equal to y0, that I said uniform flow also we can say, or we can call it as critical slope. critical slope, dh by dx is equal to 0, y0, that is one critical slope. These are the different backwater category, backwater profile category. So in that, one problem is there: a rectangular channel with the bottom width of 4 meter and bottom slope of 0.0008 has a discharge of 1.5 meter cube per second in a gradually varied flow. In this varied flow in this channel, the depth at a certain location is found to be 0.30 meter. Assume n is equal to 0.016. Determine the gradual varied profile. So here we need to draw the backwater profile diagram. So we need to find out the type of the groundwater gradual varied profile. What kind of gradual, whether it is steep slope or mild slope, or what we can say critical slope. So that we need to find out. So first, what is the formula to find the normal depth? Y0 is equal to find the normal depth. We'll solve the problem. To find normal depth, so A is equal to, we don't know the depth, A is equal to B into Y0. We can write B into, this is Y0, B into Y0. A is equal to B into Y0. So here A is equal to B, they given 4 into Y0. We don't know the depth, what kind of depth is. So perimeter we don't know. Perimeter we know the formula. P is equal to B plus 2 into depth, 2 into Y0. You know that perimeter formula. So you can calculate M is equal to, assume n value they given, which means constant value they given, n value. So M is equal to A by P. A is equal to 4 into Y0. P is equal to B plus 2 into Y0. B plus 2 into Y0. So how we can make it? This one 4 plus 2 into Y0. We can write it 4 plus 2 into Y0. So that answer is, we can write it. Next we have the formula Q is equal to A 1 by N, Manning's constant, N value, and M to the power through and I. Next we are having the formula Q is equal to A into 1 by N, M 2 by 3, I is bed slope is to the power 1 by 2. And we are having the finally of A 4 into Y0, it means depth, into N value they given 0.016 into M, the value A by P, that we know 4 into Y0 divided by 4 plus 2 into Y0, that is 4 into Y0, 4 plus 2 into depth. So into IB, slope is 0.0008 to the power 1 by 2. By trial and error, Y0 is equal to 0.43 meter. That we got the value is 0.43 meter. And critical depth, calculate critical depth. A will to find normal depth, Y0 is 0.43 meter, and critical depth we got the values because here we are having the discharge, and we will get the value of Y0 is equal to 0.43 meter. So this is the first step, but we need to find out in this equation is whether it is a what kind of profile. So this as we discussed in this before, different profile is there, backwater profile is there, mild slope is there, steep slope is there, and critical slope is there. In this, what kind of profile will create, what kind of gradual varied flow will to create, that we need to discuss in this problem. So that reasons we are using that formulas and this equation. A is equal to B, and we don't know the depth, so that is we need to find normal depth. What is the normal depth of that one? That we need to find. So normal depth equation is we are finding out according to the depth only. We are finding out the what kind of gradual varied flow this one. So that reasons we have calculated if it is dH by dx is equal to x, because it is the ನೀರಿನ height ಯಾವ ಯೂನಿಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಯಾವ ತರ ಚೇಂಜ್ ಆಗ್ತದೆ ಅದರ ಮೇಲೆ ನಾವು gradual varied flow, whether it is which kind of flow, we are deciding that one. So we will get y0 is equal to 0.43 meter. So now we need to find out the critical depth yc. That also important. Critical depth is very important. That also we need to find out the critical depth. To find critical depth. Next, so what is the formula for critical depth? Q is equal to small q is equal to, we know that one formula with many derivation we are done. Q is equal to q by p. Small q is equal to q by p. That is the critical depth formula. Capital Q, we know that one 1.5 divided by small q is equal to p4. So answer is 0.375. Answer is 0.375 meter cube meter per second. Small q is meter cube meter per second. And what is the depth? Critical depth also we need to find out. yc, that is we know that one q square by g, small q square by z, small q square by g to the power 1 by 3. So answer is 0.24 meter. So we can solve that formula, q square by g. So q square by g what is the q value? 0.35 square, 9.81 g to the power 1 by 3. So answer is 0.24 meter. Type of profile, what kind of profile this one? y0, what kind of profile? Now we calculate what kind of profile this one. We are having the different profile equations. So here, since y0 is greater than yc, critical height, normal depth is greater than critical height, so that we can say 0.43 is greater than 0.24. So this one we can say mild slope, therefore it is mild slope. We can say that is one mild slope. So that this is one of the method to calculating the different backwater profile, and how we can measure the profile in different method. So measuring the profile also, what kind of profile this is, whether it is determine the groundwater gradual varied profile. That is for that this kind of calculation is important. So please follow this problem, and it's very important problem. For this kind of problem you will ask for your final exam also. So thank you very much for listening my class.